Hello all, welcome to this session about our product CAENexus. CAENexus is an automated preprocessor which helps to automate CAE workflows. CAENexus supports CFD solvers such as AccuSolve, Fluent, CCM Plus and OpenFOAM. It supports FEA solvers such as Abacus, OptiStruct, Nastran, and ANSYS. Let us review how CAENexus works with this simple coupling assembly created in a Creo software. So this is a Creo assembly which has different parts such as bottom plate, right hub, left hub, etc. So this is one important role in CAENexus automation workflow. In this role, CAD engineer will create simulation geometry. Simulation geometry is created in any CAD software of user's choice. The next step is to give the parameters such as SComp and SClass. These parameter names SComp and SClass are recognized by CAENexus. SComp stands for simulation component and SClass stands for simulation classes. Let us see how to give these parameter values in Creo. So go to the tools and parameters and select the part such as a bottom plate and let us choose SComp type string and give the value as bottom underscore plate. Then add another parameter as SClass with string and give it as a steel underscore 1430. So similarly, user can add these parameter and its values on each part. Each CAD software has its own way to give these parameters and values. So instead of giving all the parameters and its values, let me open already created or already tagged CAD model. So here you can see that SComp values are given on all the parts such as bottom plate, right hub, left hub, etc. So these values are unique SComp values and these values of SComp represents component names. So rest all are S-class values. You can see it here, such as a solid, steel 2340, contact, load, etc. So these values represents physics of the simulation. So SComp values are unique, but S-class values are common across different parts and represents the physics. Let us see how CAENexus use these values of SComp and S-class to set up the simulation in abstract model. So this is CAENexus abstract model window. Here it is a class widget. Here it is a class relation widget. Then it has four tabs called as a meshing, solution strategy, problem definition, and output. So let me create some class called as a steel underscore 1430 and on this class let us apply continuum solid attribute of abacus. So now attribute is on steel 1430. Its element type is C3D10. its orientation is there. So anyone who knows abacus will not feel anything new in all these element types and other data, because it is all fetched from abacus documentation. As you know, in traditional process, we apply all these attributes either on geometry or a mesh. But here we are applying it on simple strings, which we call it as a classes in abstract model context. So this is the role of CAE analyst, that is to create the abstract model which will store all his CAE knowledge. So let us see all the next three step processes which are performed by machine. So instead of authoring all the AMF, I will open already created abstract model file. So here you can see it has mesh attribute defined on class size, then some solution strategy attributes like analysis process, load steps, etc. Then it has contact pairs, gravity, then material data and output data like node output, element output, etc. And this is the AMF file created by analyst. The next step is to create a simulation model. While creating simulation model, it will ask me the CAD model, and here I'm giving the CAD model which we had tagged a few minutes back. So now this abstract model is combined with the CAD model, and this real simulation model has been created. So now if you click on, let us say, class steel 1430, it highlights these three parts. Let us go back to CAD, and you can see this steel 1430 has been given on right hub, left hub and P, while steel 2340 is only on bottom plate. So let us click on steel 2340. So it is showing the bottom plate. Let us review the attribute which we created. Let us say steel 1430. It is highlighted on all these three parts, and from class it will go to its corresponding components. You can see that steel 2340 is gone on these three parts. And let us see how it goes on the model. On the model, the same attribute will be seen on real volumes of this geometry. So this is how each attribute is transferred from class to its real geometry when we create the simulation model. The next automatic step is to create the mesh, and all the mesh attributes which are here, those are considered to create the mesh, like mesh curvature, mesh size, mesh order, etc. So this mesh is getting created, and then last step is to export the abacus data here. So let me export it in export folder here. So it will start exporting, and while exporting, it will take all the data which is transferred in the model tab. So let me show you this export file of abacus. So you can see here that all the nodes are exported. After the node, I think all the elements are exported. So you can see it here. This star system, star node, star elements, then star material, density, elasticity, and all solid sections are exported here. then all the contact surfaces. So this is how export has been done in three simple steps, that is create simulation model, create mesh model, and export solver deck. Let us talk about advantages of these abstract modeling processes. So here user or analyst is specifying attributes on classes which are simple strings here. These classes represents the physics of the problem like solid, load, contact, etc. And across any two problems of FEA, this physics will remain more or less same. Hence, this abstract model file will become reusable across the organization for different problems. Second advantage is that all the knowledge of CAE analyst has been stored in this very simple abstract model file. This knowledge capturing will definitely help when other less experienced analysts or designers want to run the simulation. The third advantage is that with this process, simulations can run 24 by 7. Let us talk how this could be done with simple scripts. Let us see how CAENexus scripts can run multiple models very easy. So here I have created two models, very simple for the demo purpose, which has its CAD geometry and abstract model file. And here I have created a simple dat file which specifies the name of the model, its AMF file location and geometry location. And to run this, let me start a command prompt here, and this is the CAENexus command prompt, and let me go to this directory D, and here I have to just click on run.bat, and it will start processing both the models one by one. So behind this script, a very simple API exposed by CAENexus are working. For example, this is Python APIs like load abstract model, which loads AMF file, then load the CAD model, which loads the CAD model, then create simulation model. We saw this process through UI, then create mesh model, and finally export it. So this simple script starts working in non-UI mode, and this could be used to really automate all the workflow where everything runs in the background. With simulation process management software, this workflow is very powerful tool for the designers. So this is all about how CAENexus works. Thanks for the watching and have a nice day.